At 10:21 a.m. local time on Thursday, a magnitude 4.4 earthquake struck the St. Lawrence River in Canada, generating ground motion that was felt by up to 500,000 people. This, of course, caused no damage of any kind, so you might be wondering why I decided to make a video about that June 18, 2026 earthquake centered 323 kilometers northeast of Quebec City in the first place. The answer is that the how and why this earthquake struck is just so interesting from a scientific perspective, as parts of the St. Lawrence River can and have produced truly large magnitude earthquakes in historical times, with portions of it representing the highest seismic hazard area in Canada that is both south of the Arctic Circle and east of Calgary. To show you precisely what I mean by this, let's look at all of the known or directly recorded magnitude 4.0 or greater earthquakes which have struck this 3.1 million square kilometer region since 1663. As you can see, the area of the St. Lawrence River during that time frame was the site of a major magnitude 7.0 earthquake in 1663 and 4 strong magnitude 6 range earthquakes between 1732 and 1925. It's the most seismically active region in the vicinity, and to see exactly why this is the case, all you have to do is zoom in and look at the local geology. Have you ever wondered why the St. Lawrence River largely flows in a straight line, or why both sides of it contain linear ridges? That is because part of this river represents an ancient failed rift zone where 600 million years ago the crust slowly broke apart in an attempt to split the existing tectonic plate in two. The rifting which did occur happened in association with the late stages of the breakup of the supercontinent known as Rodinia during the opening of the ancient Iapetus Ocean. While this process failed, nearly 50 million years of rifting left behind an extensive and wide rift valley which is today known as the St. Lawrence Rift System. This long and active rift valley is what Thursday's earthquake struck within, specifically occurring on a half-graben-related fault that I interpret trended to the north-northeast. Much like seen at the Reelfoot Rift in Missouri, regional stresses from distant uneven tectonic plate motions built up on a pre-existing weak spot in the crust. In this case, the St. Lawrence Rift System, since it's the most likely feature to try and accommodate regional stress. Stress built up until a regional buried fault line slipped to accommodate it, moving in an oblique manner, specifically involving a right lateral reverse fault. Ancient failed rifts are surprisingly common worldwide and are a frequent source of intraplate earthquakes far away from tectonic plate boundaries. The St. Lawrence Rift just so happens to exist in an area that most people don't associate with earthquake hazards. Now, for clarification, I am not suggesting that a strong or major earthquake will follow Thursday's earthquake, as that, in my opinion, is absurdly improbable. In the vicinity of where the 4.4 quake struck, in historical times there has never been an earthquake of larger than a magnitude 4.5. I do want to note that the St. Lawrence Rift System contains two branches that formed at the same time 600 million years ago during the Ediacaran, representing triple junctions known as Alacougens. The first is known as the Saguenay Graben, while the second is known as the Ottawa-Bonnechere Graben, and these tectonic structures are also the sites of elevated seismic activity when compared to other nearby sections of Canada. I hope that you found this video interesting, as it helps to explain why exactly parts of eastern Canada look the way they do. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.